All right, screencast for the density worksheet. Um, we'll have talked about this in class, about using the density triangle and about how to use the density equation and how to solve word problems. So on this one, I'm going to focus on the more challenging problems on here that you may get stuck on. When you go through, remember, always look for what the question is asking for. So in number one, what is the density of a piece of wood? So your equation will be density equals mass over volume, right? Next one, what is the density of wood? And would the piece of wood float in water? So once again, this one has two things you need to answer. Well, not once again, but this one has two things you need to answer. And once again, it's solving for density. Density equals mass over volume. And then don't forget to write down would it float or sink. Number three, straightforward. Once again, it gives you the densities. You'll need to calculate the density equals mass over volume. Number four relates to number five. So it says, I threw a ball into the pool for my dog to fetch. The mass of the ball is 125 grams. What must the volume be to have the density of 0.5 grams per milliliter? So here's the first one where it probably differs from the ones before. And we will have talked about the triangle. And I'll draw it for you here. Density equals mass over volume. And this time, notice that it's asking us, what must the volume be? So immediately we know that we need to cover up volume, and that leaves us with the equation mass divided by density. So we have volume equals mass divided by density. All right. So make sure when you set this one up, that's how you begin. Now, just to remind you, it's always good to write the number and the unit. So the mass of this particular one is 125 grams. And you're going to divide that by the density, which is 0.5 grams per milliliter. So take a moment here to show you. Remember, when you have something on top and bottom of the division line, that means that these units are going to cancel when you do the math. And that's going to leave you in milliliters, which is a good indicator that you've done the problem right, because that's what you want your answer to be in, is a volume measurement, and milliliters is a volume measurement. Now, for number five, it wants to know how many milliliters of water can the ball absorb before the ball sinks. So it's still a volume question. It wants to know how many mils. So we're going to still use the same equation. The ball is not going to change its mass. It's still going to be 125 grams. That leaves us with this question of what is the density going to be? Well, we need to know when it sinks. And anything that has a density greater than 1 is when the ball is going to sink. So in this problem, that's the trick. You have to set up density as 1 gram per milliliter, and then that will allow you to solve for how much water it can take on before it starts to sink. So there's your hint on number 5. Number 6 is where you need to find the mass of a cylinder. So once again, using the density triangle, we're going to cover up mass. So the equation is going to be mass equals density times volume. So that's the way you set this one up initially. Mass equals density times volume. And it gives us the density of the lead. So we have that 11.4 grams per milliliter. But unfortunately, we don't have the volume of the cylinder off the top. So we'll have to, like the hint says, to find the mass, you need to calculate the volume. So let's do that first. And for a cylinder, there's an equation called pi r squared h. And that equals the mass, the volume of a cylinder. So let's take pi, which is 3.14, and let's multiply that by the radius, which is half the diameter. So in this case, it's going to be 1.25 centimeters, right? And we have to square that. So we're going to put our squared up here. And then we multiply it by the height of the cylinder, which it tells us it is 5.5 centimeters. Okay, so now when you look at this, look what happens. If we have the centimeters squared and centimeters, when we get our answer, the units is going to be centimeters cubed, which is a volume. So by doing this and getting the numeric answer, attaching that to centimeters cubed, we will have this answer that we can then use as our volume and solve for the mass. All right. Number 7, ice cube. So right there, in case you've forgotten, the equation for a cube is the length cubed. So in this case, if you take 5.8 times 5.8 times 5.8 centimeters, you're going to get centimeters cubed, which will give you your volume. And then once again, you're solving for mass. So use your density triangle to solve for that, and density is given. For number 9, pretty much a straightforward one. It gives you all the answers, or excuse me, all the data, straightforward. And remember, you want to know the volume of the gasoline spilled. So use your density triangle. And then finally, the density of aluminum is 2.7 grams per milliliter. If the mass of the piece of aluminum is 244 grams, what is the volume of the aluminum? All right, well, if you hung in till the end, then good for you. Let's go ahead and we'll see how much of this we can solve before time runs out on us. So we want to know volume. So our equation is volume equals, going back to our triangle, we're going to cover it up, and we're going to have mass divided by density. So we have volume equals mass divided by density. And it tells us that the mass is 244 grams. And we're going to divide that by the density, which is 2.70 grams per milliliter. Where'd my 2 go? The computer, there it is. So now we take 244 divided by 2.7, and when we do that, we get 90.37, and we cancel our grams because they're on top and bottom, and that gives us milliliters. When we're finished, circle our answer, and that's the volume of the aluminum. All right.